Hey everyone, let's jump right into a topic that is, no joke, a cornerstone of all geometry: parallel lines and transversals. Now, it sounds a little technical, I know, but it's really just about what happens when one line cuts across two parallel lines. If you can get this down, you're unlocking a huge piece of the puzzle for everything from architecture to art. Let's get to it.
And this isn't just about acing your next quiz. The sources are really clear on this. This topic is absolutely critical. Getting these angle relationships down cold is your ticket to understanding more advanced stuff in geometry and even in physics. So yeah, mastering this gives you a serious leg up.
So here's our game plan. First, we're going to meet the cast of characters in this whole 8-angle setup. Then, we'll dive deep into the 4 key rules of the game. After that, we'll put those rules to the test and actually solve some problems. And finally, I'll give you some pro tips to avoid common mistakes and really lock this stuff in.
Okay, so let's set the stage. Every single one of these problems starts with this exact same picture. Let's meet the players.
All right, here's the scene. You've got 2 lines that are perfectly parallel, right? Then you have another line that slices right through them. We call that the transversal. And boom, just like that, you've created 8 different angles. We usually number them 1 through 4 on the top intersection going clockwise, and then 5 through 8 on the bottom. These 8 angles are our main characters.
So, now that we know who's who, it's time to learn the rules. See, these 8 angles aren't just random. They're all connected by 4 special relationships, 4 rules that reveal this really cool hidden symmetry. Once you know these 4 rules, trust me, you can solve anything they throw at you. Let's dig into the first one.
First up, we've got corresponding angles. The easiest way to think about these is to just imagine taking that top bundle of 4 angles and sliding it straight down on top of the bottom bundle. The angles that land on each other, those are corresponding. So angle 1, the top left one, corresponds with angle 5, the other top left one. Same for 2 and 6, 3 and 7, and 4 and 8.
And here's the rule for them. It's beautiful in its simplicity. When the lines are parallel, corresponding angles are always equal. So angle 1 is the exact same size as angle 5. That's it.
Next up, alternate interior angles. The name literally tells you everything you need to know. Interior means they're in between the 2 parallel lines, and alternate means they're on opposite sides of that transversal line. So that gives us 2 pairs. You've got angle 3 and angle 6, and you've got angle 4 and angle 5.
And what's the rule? Well, just like corresponding angles, it's super straightforward. Alternate interior angles are equal. So the measure of angle 4 is exactly the same as the measure of angle 5. Simple as that.
Okay, you're probably seeing the pattern here. Let's talk about alternate exterior angles. Again, the name is the clue. Exterior means they're outside the parallel lines, and alternate means they're on opposite sides of the transversal. That leaves us with 2 pairs, angle 1 and angle 8, and angle 2 and angle 7.
And yep, you guessed it, the rule is exactly the same. When your lines are parallel, alternate exterior angles are also equal. Angle 2 is going to have the same measure as angle 7. Pretty easy pattern to remember, right?
All right, time for the one and only relationship that breaks the pattern. Meet co-interior angles. You might also hear them called same-side interior angles. The name tells the story. They're interior, so they're between the parallel lines, and they're co, or same side, meaning they're on the same side of the transversal. So our pairs here are angle 3 and angle 5, and angle 4 and angle 6.
Now listen up, because this is the crucial difference. Co-interior angles are not equal. Instead, they are supplementary. And supplementary is just a fancy geometry word that means they add up to 180 degrees. This is the one exception to the equal rule, and that makes it the most important one to burn into your brain.
So let's boil this all down into a super simple memory trick. Look at the names. If the name has the word alternate or corresponding in it, the angles are equal. End of story. The only odd one out is co-interior. That's your big red flag. When you see that, you know they're supplementary. They add up to 180. It's really that simple. Everything else is equal.
Okay, so we've got the rule book down. Now it's time to actually get our hands dirty and see how these rules let us solve for all sorts of unknown angles and variables. Let's put this playbook into action.
All right, here's our first challenge. We're given these algebraic expressions for angle 3 and angle 5, and our job is to find the value of x. So what's the very first thing we do? Always figure out the relationship between the angles.
Okay, let's walk through this together. Step 1. Identify. We look at angle 3 and angle 5. They're inside the parallel lines and they're on the same side. That makes them co-interior. Okay. Step 2, relate. What's our rule for co-interior? They're supplementary. They add up to 180. Step 3, solve. Now we do the algebra. We build our equation, the first angle, which is 4x plus 20, times the second angle, 2x plus 60, has to equal 180. Let's combine our terms. 4x and 2x give us 6x. 20 and 60 give us 80. So 6x plus 80 equals 180. Subtract 80 from both sides. That leaves us with 6x equals 100. Divide by 6, and you get x equals 100 over 6, which simplifies to 50 over 3. And you can always do a quick check, plug it back in, and you'll find the two angles add up perfectly to 180.
Let's run another one. This time we're dealing with angle 4 and angle 6. So, again, what's that crucial first step? Identify the relationship.
Now this problem shows us the other side of the coin. Step 1, identify. Angle 4 and angle 6, well, they're between the parallel lines but on opposite sides. That makes them alternate interior angles. Step 2, relate. What does our rulebook say about those? They are equal. This makes our algebra even easier. So for step 3, we solve by just setting the two expressions equal to each other. 7x minus 15 equals 5x plus 9. Okay, let's get the x's together. I'll subtract 5x from both sides, which gives me 2x on the left. Then I'll add 15 to both sides. 9 plus 15 is 24. So 2x equals 24. That means x has to be 12. And for our last step, we check. Plug 12 back in, and you'll see that both angle 4 and angle 6 are exactly 69 degrees. They're equal, just like they should be. Perfect.
Awesome. You now have the core skills, but to really get to that mastery level, let's quickly talk about the most common mistakes people make so you can just sidestep them completely.
Let's go through these common traps. Number 1, and this is the big one, is mixing up co-interior angles and thinking they're equal. People get in a rhythm and just set everything equal. You have to pause and remember, co-interior is the special one that adds to 180. The second trap is just rushing into the algebra without identifying the angle type first. That initial step is everything. It tells you what equation to write. And another one is just mixing up interior and exterior. Just remember, interior is in between the parallel lines. And finally, and this is a sneaky one tests love to use, these rules only work if you know the lines are parallel. If the problem doesn't say they are, you can't assume anything. So after all of that, if you only remember one thing, what should it be? It's this simple rule right here. If the name has alternate or corresponding, the angles are equal. If you see co-interior or same side, they're supplementary. That's it. Every single problem starts and ends with that one simple idea. So what other geometry puzzles do you think this one simple rule could help you solve?